All right, this video is going to be part 2 of multiple angles. This is going to be a video on why everything was so important in that last video, like how you would actually apply it. So let's get started. We're just going to do 2 quick examples. Imagine you saw something like sine 75 degrees. You're going to have to, that's not like one of your normal angles, so you don't know that answer right off the bat. So you would have to rewrite this as like sine of an angle plus an angle. So we could do like 45 degrees plus 30 degrees. And it doesn't necessarily have to be like plus. You could do like an angle minus an angle. It'll give you the same thing. So I have sine angle plus angle. So I'm going to come over here and use this equation, sine angle plus angle. And so we'll call this first angle U and the second angle V. And then you just kind of go plug it in. So it'd be like sine U times, sorry, it's cosine, times cosine V plus cosine U times sine V, like this. And so now you're just going to go get the actual values for these things. Just one thing I will say is everybody always messes up on their negative signs. So pay attention to what quadrant you're in. Luckily for us, these will all be in quadrant 1. But if it wasn't, if it was anything different, you would really have to think about what quadrant you're in and if it was positive or negative. So sine 45 is root 2 over 2 times cosine 30 is root 3 over 2 plus cosine 45 is root 2 over 2 times sine 30 is a half. So when you multiply these roots, you can multiply them. You just can't add or subtract them. So like this first part will become root 6 over 4 plus, and the second part will become root 2 over 4. And then you can just combine your numerators, but you can't make it root 8. So this would be my answer. All right, this next one, tan 5 pi over 12. You could do this as an angle plus an angle, but I'm going to show you that it doesn't matter. You can do it as an angle minus an angle. So like, what if I did tan 9 pi over 12 minus 4 pi over 12? So I'm going to reduce these fractions. 9 pi over 12 is 3 pi over 4. And 4 pi over 12 is pi over 3. So these are probably looking a little more familiar to you. And so it's tan angle minus angle. So I'm going to be using this equation right here. And then I'm just going to call this first angle U and the second angle V. And I'm going to go plug them in. So it would look like this. Tan U minus tan V over 1 plus tan U times tan V. All right, now I will say tans can get kind of weird. So my advice to you is write out the reference angle. So like pi over 4 is root 2 over 2, root 2 over 2, and pi over 3 is 1/2 root 3 over 2. This will just help you when you go to answer these tans. So, all right, you will have to pay attention to what quadrant you're in. So what I mean by that is 3 pi over 4 is in quadrant 2. Tan is negative there. So this first part is negative 1. Tan pi over 3 is root 3 over 1, so just root 3. And it's over 1 plus tan 3 pi over 4 was negative 1. And tan pi over 3 was root 3 over 1. So like this. So you'll get 1 minus root 3, sorry, negative 1 minus root 3 over 1 plus negative root 3. So really just 1 minus root 3. And for most of your teachers, that would probably be an acceptable answer. But if you're looking to do this perfectly, you're going to need to start rationalizing your denominators. So you got to hit this with the conjugate, 1 plus root 3 over 1 plus root 3, because you're not supposed to have roots in your denominator. So on top here, you're going to have to FOIL that out. So you're going to get -1 minus root 3 minus root 3 minus 3 over, on bottom it's a difference of squares, 1 minus 3. So when it's all said and done, you get -4 minus 2 root 3 over -2. And then if all of these numbers reduce each other, these guys, then you have to reduce it. So you don't touch this root, you just leave that root. So it would look like this. I'm going to reduce them all by -2. So I'm going to get 2 plus root 3 over 1, or just 2 plus root 3. I hope that made sense. This all in pink, this is all kind of a little extra, but it's how to properly do it. So this is how you would actually apply these equations. Hope this video helped.